Hi, welcome to the Air Manager API tutorial video series. So in the last couple of videos I've kind of just explained the outline of what we need to do to start getting coding with the API functions within Air Manager. Talked about code editors, graphic editors, the Sim Innovations wiki site, and a little bit about the interface of the Create Edit tab within Air Manager. One thing I did forget on that last video series was just to say that a lot of these functions here within Air Manager are also accessible by right-clicking on the gauge here. You can see a lot of these functions here just are also available by just a right click on the instrument. So if that's something that you need or you find easier to work with, then that's also available with a right click of the instrument. So let's get started with the first API function, I guess. So as I showed originally, I'm going to click the API button there just to bring up the wiki with the list, take me straight to the API instrument logic API page. And so we're going to start, for want of a better place to start with the very first function to do with subscribes and subscribing to data within the sim. So we're going to look at the X-plane ones first, then we're going to move on to the flight simulator prepared subscribes and how to write to events, and they're called commands in X-plane, but you'll see how that happens. We're going to run through the wiki examples and maybe elaborate on one or two of them just to show some of the slightly different ways that they can be used. So we'll start with XPL dataref subscribe. That's short for X-plane dataref subscribe, and it's a way of subscribing to data within the sim to drive instruments within Air Manager. So we'll click on that. You can see it brings up its own page just for that function, and in this particular one has 3 examples, but it also gives you the outline of the command itself and a description about each of the arguments that are used within the function. And with the examples you get an idea of perhaps how to use them, but we'll talk about each one a little bit and see how we get on with that. So I'll bring up my code editor, and what I've done, there we go. So what I've done is each of the examples within the on the API wiki page, I've pasted into my code for the API instrument that we created last time, and you can see here I've just commented out the XPL dataref subscribe for the last 2. So we're just going to concentrate one at a time. So we're just going to leave this one up first, and I'll explain basically what's happening with each one as we go through. So we'll go back to the web page just very quickly. You can see here XPL dataref subscribe requires dataref, dataref type, and callback function. They're explained here in the arguments, but essentially what that means is dataref is the name of the dataref. Now, we looked at the datarefs before. I've got them open here. You can see there's a big long list of datarefs here. So there'll be something like this: sim, aircraft, limits, red hire, MP. They're all called different things. They're all quite unique, but it also against each one. So that would be the name of the dataref. The type. So going back to where it says data type, it says here the dataref can be an int, float, double, in an array, float array, double, byte, string. So lots of different data types that you can use, and really that's not for you to worry about too much, because those data types are already set up in the sim. So you go to your list there and you can see here that there's a float, non-array type float, that's a byte, there's an int, what else have we got here? Mainly floats. There's a float with an array type with a number in there. So there's lots of different types, and there's I think I just saw down the bottom there was an There you go. So there's an integer in an array, or set of integers in an array, and I'll explain if you don't know what an array is or how to use an array. That's one of the examples that we've got over here on the right. So that's a good resource for finding out which dataref. That's half of the battle in trying to find out which dataref you want to get information from. They give a bit more information, whether they're readable or writable. These ones mainly are writable here, but there will be a lot of them that see these ones are no, so they're not writable. You can only read from them. And then just telling you what the units for the particular thing is, and then a brief description about what it is. I think I've spoke about that before, but it's worth just touching on that again, because that's pertinent to what we're going to discuss here. So the actual command that we're talking about in this video is xpl dataref subscribe. So we're going to subscribe to a dataref within Xplane. In this particular case, the example on the wiki, the dataref that we're subscribing to is altitude in feet for the pilot's instrument. There is a Copilot version of this as well, so that's the differentiating _pilot on the end there. So that's the full path of the dataref, if you like. We put that in first because that's the first argument from the example here. So dataref is the first thing that we put in, then the type, and then the callback function. So, whoops. All right, we'll leave that there. Okay, so there's the dataref. The type is a float. If we were to look that up in that big long list, we'd see that altitude feet pilot is a float value. And then the bit on the end, the callback, is a unique name, whatever we want to call it. So in this particular example, it's called new altitude callback, and this needs to match the name of the function. This is going to call a function, so we've created just at the top here a function called new altitude callback. That's the same name you can see here. Okay, so this new altitude callback can be whatever you want it to be, but it's got to match this name here. The other important thing to remember is that when this piece of code is actioned here, this is running in order. So 1, 2, 3, 4, 5, 6, 7, from top to bottom, the code is run in order. So if we're going to call a function in this Xplane dataref subscribe, that function needs to exist already. If we were to put this at the very beginning, then calling the function and having the function later on in the code would be no good. Unless, of course, we're putting everything in functions and we use something else to control the order in which the functions run. But we're not going to get into too much detail about that here. But it's important to note that if you're going to call a function, the function must have already been defined previously in the code for this not to throw an error. So the function is very simple in this example. All functions start with the word function and then the name of the function, and then they end with the word end, and then everything in between the function and the end is the contents of that function. Now this particular function with the Xplane dataref subscribe, each one of these subscribes, and the two main parts that you need for the subscribe are the name of the dataref and the dataref type, in this case float. That is one lot of data, or one variable that the sim can give back. So in this particular example, because we've only used one dataref, and one of the other examples coming up later on has a couple, but you can put 10 or 20 of these things in a subscribe statement. You only need the one callback for that. So in this particular case, we've only got one, so we need one callback for it. So there's only one piece of information, so there's only one variable name in the brackets here after the function name. We happen to have called it altitude. Again, we can call it whatever we want. And in the function code, it just says print new altitude, and then takes that variable altitude and puts that number in there. So if we go back to Air Manager and run our instrument, when we press run, we still get our little blank white instrument that you can just see off to the side here. You just saw it load, and you can see it's running. The sim is running, and we've got new altitude here, and this number is it's a float value, as you can see. Very small changes to the number here because we're not actually climbing or descending. But if the aeroplane was flying along and you were doing a climb or you were doing a descend, then obviously the bigger digits here would change and you'd get a different altitude. But as that updates, every time the sim sees different set of data, as it's seeing here, it's changing ever so slightly all the time. That data ref updates quite a lot. You're getting a new print statement being actioned because every time this sees a change in sim data from the sim, it calls this function. So it's continually doing that all the time, as you can see here in the example. The other important thing to note is that here now in the subscriptions window, it shows all the subscriptions that are part of our gauge. Now at the moment I've got these ones edited out, as I said earlier. Only this one is valid, so the only subscription we've got is for Sim Cockpit 2 Gauges Indicators Altitude Feet Pilot. You can see it's in there. Now what I can do is I can, for testing purposes, I can manually enter something in there. I can, because this one is writable, I can change that to 1000 and click send, and you can now see 1000 is being returned back from the sim. So it just says new altitude, and then the actual data. Okay, so that's not actually coming from the sim, that's now this manual interaction here with our gauge. We can stop that and we can rerun that again, and this 1000, although it's still in the box, we haven't actually clicked send yet, so it won't action that again. So that's kind of a one-off type thing. You can refresh the gauge again and it'll start getting the data directly from the sim again. So very useful for testing. So that's a subscribe. That's very basically what you would do with a subscribe. Essentially, you put lots of it. This is only a print just to show the information, but you can use that variable now, that altitude variable, to display the altitude or to move a needle a certain amount on an altimeter, depending on the subscription and what you want to do with it. But your code for actually interacting with the instrument would go in the function here, or you may even have a call to another function where you do something. So, but essentially this callback, or this name of this function, returns back to here, and then you can do whatever you want after that that point in time. So what I'm going to do now is I'm going to edit out this one, and I'm going to unedit the next example on the wiki page. So the next example shows an example of an array data ref. So they're slightly different in so much as an array is just a collection of single data bit values, but in a group or a table. It's called an array. It's quite common in programming talk, if you like. And when you look at the data ref type, when you look up the data ref, you look up the data ref name. In this particular case, it's an engine related one for engine fuel flow, but you might have more than one engine on your aircraft. So rather than have lots of different data ref names in X-Plane, what they do is they put all the different information for that one parameter, fuel flow, and they have an array. So essentially that's saying that I've got 8 bits of data, because we've got number 8 in here. I've got 8 bits of data, so I've got up to 8 engines worth of fuel flow data. Now obviously if you've only got a single engine aircraft, you'll only see data appear in the first one, but on a twin you'd see it in the first couple, etc, etc. So it works very much the same as the first one. We've got the X-Plane data ref subscribe. There's the name of the data ref. In this case, the type of data ref is a float, and it contains 8 bits of data. And then the name of the callback in this particular instance, again, it can be unique. New PT RPM callback, which is the name of the function here, new PT RPM callback. Again, this only has one. Although there's 8 bits of data within the array, it only has one chunk of data, which is the array itself. So it's like a table of data. So in this particular case, we've called it engine fuel flow. That's our table of data. And then in the print statement within that function, we say array contains. This is just a little statement that returns the number of that array. So it basically looks at that table and says, give me the number of elements within that table. So in this case it will be 8, so that should say array contains 8 items. When we run the instrument we should see that, and then after the full stop, data on the first position is, so we can then access each of the individual elements of that table by putting its reference ID here in the box after the engine F. So engine FF is the name of the array table, so we're saying from that array table give me data item number 1, so for the first engine, for the second engine 2, 3, etc. So we should be able to get the fuel flow data for engine 1 when we run the instrument. So we've got the first and the last commented out, just the second one left there. So we're going to click save here. So you have to save your code now. This is the new code. So when I press run now on the instrument, it should run this new code. Open Air Manager. There's our API tutorial. Press run. You can see there it says array contains 8 items. That was the array size, and data on the first position is 0. Okay, so again, if you had meaningful data and you had something running that was continually updating, you may see this iterate round. You may see lots of these appear. It's important to note that in this console window, this bottom window here, the item at the top is the newest. So if you've got multiple ones like you saw in the last example, the ones further down are older than the one at the top. The one at the top is always the newest. So if it's continually updating, the newest data is coming in from the top rather than being added onto the bottom, just so that it's fresh that way. So it's important to know that if you've got, say, 2 or 3 statements in your code when you're troubleshooting, the one at the bottom of those 3 statements will be the oldest, or the one that gets run first in the code. So if you put 3 print statements in your code, the first print statement will appear here, the second one will appear there, and then the last one in the code will appear at the top because it's the newest. So we'll press stop, and then in the last example, for explain dataref subscribe, we'll edit out that second example and we'll unedit this last example here. So all these are from the wiki, as I said, and in this example it demonstrates how to use 2 subscribes within the same explain dataref subscribe statement. So essentially we can, as I explained when I was talking about this one, we could have 10, 20, 6, 8, whatever number you want in terms of the number of subscribers. So you can do them all in one function, callback, or you can split them into smaller chunks, however you want to sort of divide up your code, and whichever is pertinent to. You may decide you want to put all the airspeed ones together, all the altitude, or ones related to engine, depending on what they're for. And how often you want the callback to be run, etc. So in this example, we've got 2 different data refs that we want to look at, and you can see now we've only got 1 callback, as I explained before, because you only need 1 callback for each explain data ref subscribe. So this unique function name, you only need to be there once. So if this was a list of 20, you'd just see all of these listed 20 and just the name of the function at the very end, after the last comma of the name of the data ref and the data ref type. You could see as many as you want of those and the function name at the very end. So in this particular case, we've got an altitude and an airspeed data ref, both float data types, and we're going to call back the function new altitude and speed callback. So there we go, function new altitude and speed callback. But this time you can see in the brackets here after the function, we've got 2 parameters because we have 2 data ref items. So if we had 10, you should see 10 variable names there with separated by commas. Again, we can call them what we want. In this particular case, we've called them altitude and speed because they relate to the 2 data refs. You have to put them in order. So whichever one comes first is the first name, whichever one comes second, etc., etc. So very simple, just like the other examples. The print statement just basically now gets both of those bits of data. Altitude equals altitude there, speed equals speed. So we'll run that very quickly. Let's not forget to save it. Run our instrument, and there you go. It says altitude equals that. There's the float value, and speed equals that. There's the speed value. So that really is quite straightforward. The FSX version of that is very simple, and there is a generic subscribe as well, where you can subscribe, and it's the one I tend to use. We'll get on to that one, where you can mix FSX and Xplane subscribes together if you want to. I tend to keep mine separate, but it's one statement, and there's an extra argument within that subscribe where you tell it what sim at the very beginning that you want to get that subscribe from. So, but very, very similar in operation to Xplane dataref subscribe. So next time we'll be looking at dataref write, and then we'll move on to the command functions.